The next reaction, or the third reaction, is acids with carbonates. They produce salt plus water plus CO2. Remember, carbonate is anything, it's CO3 2 minus. It's generally a metal carbonate or an ammonium carbonate. A metal carbonate could be sodium carbonate, for example. I have sodium is in group 1, it's Na plus 1, and CO3 is 2 minus, so it's going to be Na2 CO3. That's sodium carbonate, or it could be ammonium carbonate, which is ammonium is NH4 1 plus, and carbonate is CO3 2 minus. So it's going to be NH4 2 CO3. So when we talk about carbonates, we're talking about metal carbonates or ammonium carbonates. So acids are going to react with carbonates to produce salt, water, and carbon dioxide. The salt is going to be produced in exactly the same way. The only difference now is that in addition to water, you also have carbon dioxide. So water and carbon dioxide are the two additional products. So the only thing that you need to figure out is the salt that's going to be produced. So I'm going to start off with a simple reaction. Let's take a simple acid. Let's take nitric acid first. And then we're going to move on towards carboxylic acids. So I'm going to react nitric acid with sodium carbonate, which is Na2CO3. And the salt is going to be produced in exactly the same way. The hydrogen in the acid is going to be replaced by the metal, which in this case is sodium. So sodium is going to replace the hydrogen over there. So it's going to become sodium nitrate. So instead of this hydrogen over here, we have sodium in its place. I've replaced the hydrogen in the acid with the metal. So sodium nitrate is one of the salts, and the rest is water plus carbon dioxide. So H2O and CO2 are going to be produced along with this salt, which is sodium carbonate. Now there are two sodiums, so there should be two molecules of sodium nitrate, which means that there should be two nitric acids, and the rest of the equation looks pretty much balanced. So that's your reaction of a normal acid reacting with a carbonate. Now we're going to move towards a carboxylic acid. Let's take ethanoic acid. The reaction is exactly the same. Let's react ethanoic acid, which is CH3COOH, or I can draw the structural formula, which is that eth has two carbon atoms, and since it's a carboxylic acid, there's going to be a carboxylic acid functional group, and to complete the bonds there should be 3 hydrogens over here. So this is ethanoic acid. I'm going to react it with sodium carbonate, which is Na2CO3. And remember, the salt is going to be produced in exactly the same way. The hydrogen in the acid, which is this one, the carboxylic acid hydrogen, or in the structural formula, it's this hydrogen in the carboxylic acid functional group. This is the one that's going to be replaced. So this hydrogen is going to be replaced by sodium metal. So I'm going to replace the hydrogen in the carboxylic acid. So it's going to become CH3, COO minus 1, and Na plus is going to take the hydrogen's place. And the charges are balanced. Similarly, I would do the same with the structural formula. So it's CH3, and instead of the hydrogen, I'll have sodium ions in its place. And in addition to this salt, there's going to be a water molecule and a molecule of carbon dioxide produced along with it. And the name of this salt is going to be sodium ethanoate. So it's done in exactly the same way. Water molecule and carbon dioxide are your additional products in this case. So whenever a carbonate reacts with an acid, a carboxylic acid, the salt is going to be produced in exactly the same way, and water and carbon dioxide are going to be your additional products. You can do a few more examples. Let's do another example of butanoic acid. Let's take a butanoic acid. Butanoic acid is going to have 4 carbon atoms, and since it's carboxylic acid, it's going to have this carboxylic acid functional group. The rest of the bonds will be completed by attaching hydrogen. So this is butanoic acid. and I'm going to react it with magnesium carbonate. Mg is in group 2, so it's going to be Mg2 plus, and carbonate is CO3 2 minus, so it's going to be MgCO3. So that's my butanoic acid. The salt is going to be produced in exactly the same way. Butanoic acid has 4 carbon atoms. So I'm completing the structure now. And it's this hydrogen that's going to be replaced. The carboxylic acid hydrogen is going to be replaced. So I'm going to replace it with Mg. But the problem is that Mg has a 2 plus charge. So that would mean, to balance out the charges, there should be 2 ions of butanoate. So that would be the formula. This would be magnesium. This would be magnesium butanoate, and plus we're going to have water and carbon dioxide. So there's going to be water and there's going to be carbon dioxide alongside this. So magnesium butanoate would be my salt. I'm going to replace the H with the metal in this case. So I'm going to write down the compressed version of this. So it's going to be CH3, then you have CH2, then you have another CH2, and then you have COOH, plus I'm reacting it with magnesium carbonate, and it's going to produce magnesium butanoate, which is CH3, CH2, and then you have COO minus 1, and you have Mg2 plus. The H at the end gets replaced. So they're going to be 2 butanoate ions, and you're going to have water and carbon dioxide as the additional products. The only thing is that you need to balance the equation. So since there are 2 butanoate ions, there should be 2 molecules of butanoic acid, and the rest of the equation looks balanced. It looks pretty much balanced. So that's a reaction of butanoic acid with magnesium carbonate, and you get magnesium butanoate plus water plus carbon dioxide. Let's do a slightly more difficult example now. Let's say I have ethane dioic acid. You don't need to know the name of this carboxylic acid for O levels especially. So I have ethane dioic acid. It's just an acid which has 2 carboxylic acid, and since the name has eth, it means it has 2 carbon atoms, and it has 2 carboxylic acid functional groups, so 1 on each side. So this is ethane dioic acid. I'm going to react it with let's say potassium carbonate. Potassium carbonate, K is in group 1, potassium is in group 1, carbonate CO3 has 2 minus charge, so I'm going to react it with potassium carbonate. Now again, the salt is going to be produced in exactly the same way. What's going to happen is that the carboxylic acid is going to lose its hydrogen ions. It's going to lose those hydrogen ions, so, and they're going to get replaced by potassium. So I'm going to, this would be my ethane dioate ion. So it's O minus 1 and O minus 1. So there's a minus 1 charge on both sides, and in total this ion is going to get a minus 2 charge. So in total it's going to be a minus 2 charge on this ion because it has lost 2 H plus 1 ions. So they're going to be, since K is in group 1, it has a 1 plus charge. I'm going to replace those hydrogen ions with potassium. K has a 1 plus charge, so they're going to be 2 potassiums. To substitute, you would need 2 potassiums to substitute 2 hydrogen ions. So it's going to be K2, and ethane dioate ion would be next to it. So this would be the formula of the salt that is going to be produced, and the other thing that's going to be produced is going to be a water molecule, and there's going to be a carbon dioxide molecule, and you need to balance this equation. This equation looks balanced already. The other way to write this equation would be its compressed notation, which is going to be if I write the compressed notation, it's going to be COOH, and there's going to be COOH on the other side, and then you have K2CO3, and the product that would be formed in this case is going to be, there's going to be COO and COO. This -1 on charge on this side and a -1 charge on this side, and K1 plus would be on one side and K1 plus would be on the other side. This is another way of writing the same thing. So this ion over here, it would be surrounded by two K plus ones, and there's going to be a water molecule produced and a carbon dioxide molecule produced along with it.